Okay, so the question is asking, given this molecule, how do you make it? Okay, so this thing probably looks very complicated, but let me break it down step by step. Um, this is how a lot of these organic reactions are gonna be drawn. Okay, but let me show you like what this thing is, what this thing is, and stuff like that. Okay, okay. So when it comes to a synthesis, you always start with the product, right? So for these, you start with the product, so you know what the product is. So you have to figure out, well, how did they get there? So here's what I like to do. When it comes to figuring out how they got there, you gotta figure out the parts of the molecule that have like a functionality. Okay? So I see off rip that there's something going on with this. So let me show you what I mean. Here are the sorry. Oh. Copy. Okay. Now, here are the two pieces of this molecule that can be separated, right? We can't really, so we're not really going to separate things here or here, right? We're going to keep the ring, okay? This tritium is important because tritium, just treat deuterium and tritium like hydrogen. So treat this like a terminal hydrogen, okay? And so that means that treat this like a terminal hydrogen. Sorry, I just want to make sure I don't lose anyone. Okay. So if the pieces are this and this, that means something had to happen for them to come together into one structure. Okay? And I know a couple things. In order to make these two things happen, I gotta figure out what chemistry can go down between this bond and this tritium. So that means I need to run a reaction with this as one of the reactants, and another molecule with this T on it, right? It can be anything. So let's just do T2O, similar to H2O, right? If this was a H, I would just do water, okay? So we have our structure. Now, I don't know how far in the book this is, but in order to for you to be able to run a reaction with a terminal alkyne, you have to put a lone pair on it, and that means you have to pull off the hydrogen that's already there. So in order to do that, you just maybe run it with like NaNH2 or a carbanion, but normally it's NaNH2. And then what will happen is that this is extremely basic, so this will pull off this hydrogen, giving us a lone pair. Then we can run that with just T2O, right? Our made up molecule. We only care about the fact that it has a T. And now we're gonna run this. This is gonna, hold on, let me just make it more a little, well, let me make it a little more artistic. Artistic, yeah, wow, I can't even talk. Wow. Just had a nap, guys. Okay, so we have made our alkyne anion, and now we're gonna run it with this T2O, so it's gonna attack a T, and that's gonna pop off, and then our final product will be this. So that is why the answer, this is the final product. So this is right, this is the synthesis. So we just showed each little step, and that's why the answer is this. In the first step, we did that NaNH2 to pull off that terminal hydrogen to make a lone pair. And in the second step, we ran that lone pair alkyne with T2O. We pulled off that tritium in order to tag it on to the end of the alkyne, and then it's just going to have an OT on the side, but that's not important. So that's how you do that question. It's a little much, but it's important to do it because it helps you think about how these reactions work.